In the previous video, I introduced the concept of using a magnetic compass. Let's dig into the library that we'll be using for our particular magnetic compass. We'll be using this library from Programs, and you can install this from the command line. I happen to favor using the Arduino IDE for installing libraries. So bringing up the Arduino IDE, if you click over on the left-hand side to the Library Manager, you can search for this particular device, the QMC5883L. And scanning through here, you'll find a variety of different libraries. Some of these we might take a look at later. In fact, we also have available this MPU6050. But I've chosen for this exercise for us to use what I found to be the simplest library to use, with the most functionality that we might actually use and no more. So if you scroll down and you look for the library by Programs and click Install, it will then install it, and we can use it both from the IDE and using the command line interface. I hope you'll forgive me for this next part, but I almost always start with looking at the examples, and this will be off the screen for you. But if you go up to, after having selected the Arduino IDE, if you go up to File, go to Examples, and scroll all the way to the bottom and look for Examples from Custom Libraries. Like I said, this isn't being shown on the screen. You then can look at the different examples that are available. And I would almost always start by scanning through the given examples before writing anything on your own. In fact, I would look through these before reading the documentation even, just to see how complex it would be to use this device. And as you can see, it's as simple as including the library, creating a compass object, and it follows a pretty similar pattern that we use. We've got a no argument constructor being called up here. It calls init, we usually call this setup. There are some additional parameters that we can set, and then inside the main loop we can grab some values and display them. Unlike what I'm allowing you to all use, they do use a delay here in their example. Before connecting this up and running the examples, it would be good to know how to wire this, and they do give a nice board hookup reference here. So for connecting to the magnetic compass, you'll need to power it, and this one says to 5 volts, but we'll be using a 3.6 volt source. You'll be connecting ground to ground, and then there are 2 pins for communication between the microcontroller and the magnetic compass, and they use the SDA and SCL lines. This has them listed as A4 and A5, but given that this magnetic compass is referencing an Arduino Uno or Nano, it's always worthwhile to make sure that for our particular device you would use the same pins. So in fact you can see that SDA is also A4, SCL is also known as A5, which happen to be the same ones that are being referenced here. Still, in code, I would venture to say you should use the SCL and SDA globally defined variables instead of A4 and A5. You're just less likely to come into problems if you do it that way. So for example, if you look at my code for interacting with our display, you can see I'm telling it directly SCL and SDA instead of worrying about calling those A4 and A5, which I find more confusing than needed. So as part of your exercise this week, you'll be creating a compass.h file, and it'll follow a pretty similar format here. You'll include a library, except for this time it'll be this library. You'll have a member variable, so instead of this being a global, it'll belong to a class. Inside the constructor, you'll initialize any variables we're using, and inside the setup method you'll be calling compass.init. I'll put more details in the exercise portion of this chapter, but the functionality we will care most about is the ability to grab the azimuth, which is going to be sort of our heading to north. Or maybe a better way to say that is the degrees to north from our current heading. I would encourage you to look through the documentation, look through the examples that are given. But in the end, what we're going to end up with is a pretty simple class where we read from the compass and get the azimuth. That'll then be used to sort of correct errors that accumulate from our wheel encoders. All right, thank you, and good luck on this week's exercise.